All right, we left off talking about local linearity. All curves have a slope at every single point because if we zoom in on a curve enough, it looks like a straight line, and straight lines have slope. And we talked about calculating this requiring a limit. So I'm going to show you how to do this on Desmos. So you want to plug in your function as f of x equals. In this case, we're going to do square root x. Okay, this is our average rate of change formula. Again, this is y2 minus y1, right? This is the y value at x equals 4, f of 4, over x2 minus x1. And we're going to let our x2, f of x2, which is y2 over x2, be a. And then when you type in a, it's going to ask you to add a slider, which you should do, right? And you're going to get this slider that I think it's going to say it's going to go from negative 10 to 10, all right? And then what we want to do is you want to click on, I think if you click on just either of these numbers or maybe even here, it'll allow you to change it. And you should make it go from 0 to 4, because what we want to do is we want to let x approach 4 so that these 2 points become really close together. Okay, so do that. This is just my cursor, but right now a is equal to 0, okay? Once you have that, you can just click and drag, or you can hit the play button and watch it change over time, but you can just click and drag until a is really close to 4. In this case, I made it go to 3.98, and this will tell me, this is the approximation. This is the approximation of the instant slope, right? This is just allowing us to take a limit as x approaches 4, right? We're in this case, think of x as being a. A is getting really close to 4, and this is allowing us to calculate the average rate of change. And we can see as these 2 points get really close together, it seems like that instantaneous slope is approaching 0.25. Okay, so let's try it again, but this time at x equals 16. So we're still using f of x equals root x. Okay, we're gonna change this to 16 and 16 because now we're doing the instantaneous slope at x equals 16. You should click back on here so that you can change this from going to 0 to 16, and then click and drag until a is really close to 16. Another thing you can do is just click right here, and then you can type in whatever number you want. So you could type in like 15.9 or 15.9999, whatever you want to do. This is helping us do this limit, which is the instantaneous slope. This is the instant slope at the point x equals 16. What's y equal to? What's square root 16? That's just square root. That's just equal to 4, right? And so the instantaneous slope, the slope of the tangent line at 16 comma 4, is just equal to 0.125, which is a pretty flat slope, a positive slope still, but pretty flat, right? Okay, so let's try another function. We'll do x squared at x equals 3. So what you're going to do is you're going to replace f of x equals with x squared. And then we're going to do f of a minus f of 3, because we're at x equals 3, over a minus 3. And then we should let our a go from 0 to 3. Notice that if I let it equal to 3, I get undefined. Think about why that is. Why am I getting undefined when it equals 3? And then now let's change it. I just typed in 2.999, and what Desmos is telling me is that is really close to it's equal to 5.999, which is really close to 6. And if you experiment with this and add more 9s here, you're just going to see this is going to keep getting closer to 6. So it's reasonable to estimate that this limit would be equal to 6. And again, this is the instant slope. This is the instant slope of x squared at the point 3 comma 9, because 3 squared is 9. Okay, so your last step here is you're going to find the instantaneous slope at x equals 2, 4, and 5 using this same method, and see if you notice a pattern between the x value related to the slope you're calculating. And then we're going to do 1/3 x cubed as another function, and we're going to go do 2, 3, 4, and 5. Remember, you already did 3 in the example back here, so we did not do it again, but we're going to do 2, 3, 4, and 5 for this function. It might seem kind of weird that we have this 1/3 out front, but there's a reason for that, and as we get more into patterns, you'll see why I did that for this particular example. But that's, so I'm just going to, your function should be f of x equals 1/3 x cubed. And then you're going to do the instantaneous slope at these different x values and fill those into your Google Doc. And that is all we have for today.